Okay, let's continue with problem set 3, which is mostly multiple choice questions. And so probability questions such as what is the probability of obtaining this event and that event typically call for the multiplication rule, division rule, subtraction rule, or addition rule. Well, this and that is the multiplication rule. Probability questions such as what is the probability of obtaining this event or that event typically call for that is the addition rule. And there are really no division or subtraction rules. Probability questions such as what is the probability of obtaining this event and that event typically involve which sign? Well, it's the intersection. Probability questions such as what's the probability of obtaining this event or that event? That's the union, and that's B. A sample space consists of 80 separate events that are equally likely. What's the probability of each? Well, that's 1 over 80. Okay. A mother is blessed with triplets. How big is the sample space? Ways of having children. Well, that's 2 raised to the 3, so that should be 8. And this is because the first could be a girl or a boy, and then the second could be a girl or a boy, and the third could be a girl or a boy, girl or boy, girl or boy, girl or boy. So the sample space is the set. Okay, we can have girl, girl, girl. Then we can have girl, girl, boy. Then we can have girl, boy, girl. Then we can have girl, boy, boy. Then we can have boy, girl, girl. Then we can have boy, girl, boy. And we can have boy, boy, girl. And the last one is boy, boy, boy. So this is 1, 2, 3, 4, 5, 6, 7, 8. So that is the sample space. So there are 8, and what you have, what I just erased, is 2 raised to the 3, 2 times 2 times 2. So the answer is 8. Okay, how big is the probability that the mother will give birth to 2 girls and 1 boy? Okay, now we can see, because the probabilities are the same, so how many the mother will give 2 girls could be girl, girl, boy, that's the first one here. Girl, boy, girl, number 2. Girl, boy, boy, no, here. Boy, girl, girl. Boy, girl, boy, 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 girl, so there are 3. And it's 3 over 8. A mother will be blessed with triplets. How big is the probability that the mother will give birth first to a girl, then a boy, and then again a girl. Oh, okay. So that is only one of the 8. So what is it? Girl, boy, girl. So girl, boy, girl. There's only one sequence. So that's 1 over 8. A mother will be blessed with triplets. How big is the probability that a mother will give birth to at least one boy? That is 1 minus the probability all girls, right? Because if I subtract girls, girls, anywhere else there is at least one boy. And that's 7 over 8, so both answers A and B are correct. Okay, on a multiple choice test, each question has 4 possible answers. If you make a random guess on the first question, what's the probability that you are correct? Well, that's 1 over 4. A die with 12 sides is rolled. What's the probability of rolling a number less than 11? Well, that's 10 over 12. And 10 over 12 is the same as 5 over 6. A bag contains 6 red marbles, 3 blue marbles, and 7 green marbles. Okay, so there are a total of 16 marbles. If a marble is randomly selected from the bag, what's the probability that it's blue? Well, that's 3. There are only 3, but there are a total of 16, 3 over 16. A polling firm is hired to estimate the likelihood of the passage of an upcoming referendum obtained. The set for survey responses to make its estimate. The encoding system for the data is 1 for, 2 against. If the referendum were held today, okay, so this is the empirical approach, obviously. So how many do we have in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. How many ones do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 over 20, so that's the same as 6 over 10, or 0.6. The data, the data set represents the income levels of the members of a country club. Estimate the probability that a randomly selected member earns at least 91,000. Okay, again, how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So it's again 20. Okay, how many have more than 91? This one, this one, this one, this one, 91 or more. This one, 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 this one. Okay, unless I made a mistake, should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, 1, 2, 3, 4, 5, 6. Oh, I forgot here 1. So 14 over 20, so that's 70%. Okay, when using a single die, what is the probability of rolling an odd number? Well, the odd numbers are 1, 3, and 5 out of 1, 2, 3, 4, 5, 6. That's 1/2. A bag contains 3 red marbles, 5 blue, and 4 green. So n is 12. What is the probability of choosing a red marble? 3 over 12, which is the same as 1 over 4. The probability that a student will fail a statistics test is 0.32. What's the probability that a student will pass the statistics test? So that's the complement, and that is 0.68. When a single card is drawn from an ordinary 52 card deck, find the probability of getting a red king. Okay, so in a deck of cards we have 4 times 13, 52. N is 52, and there are 2 red kings. The king of diamond and the king of hearts, so that's 2 over 52, so that is the same as 1 over 26. So 2 over 52. Okay, so assume you want to find the probability of getting a queen or a heart from a single card draw from an ordinary 50 card deck. Then the events queen and heart are said to be mutually not exclusive, or actually not mutually exclusive. You can have both. The probability of drawing a queen or a heart from a 50 card deck is, okay, so that's the probability of queen, or, that's the union sign, heart, is, because the events are not mutually exclusive, we would say that's the probability of a queen, addition rule, plus the probability of a heart minus the probability of queen and heart. So probability of a queen, there are 4 queens in it, which is 4 over 52, plus how many hearts are in there? 13. How many queen of hearts are in there? 1. So the probability is 16 over 52, which is the same as 8 over 26 or 4 over 13. So the answer is 4 over 13. Okay, again, a bag contains 15 balls numbered 1 through 15. What's the probability of selecting a ball that has an odd number and is divisible by 5? Okay, so again, those are not mutually exclusive events. So we want to know the probability of odd. Oh, and so that's the multiplication rule, and is divisible by 5. I just write it like this, divisible by 5. Okay, so what's the probability that it's odd? Times the probability, it's a divisible by 5. Okay, how many odd numbers do we have? 1, 3, 5, 7, 9, 11, 13, 15. So there are like 8 over 15. So again, 1, 3, 5, 7, 9, 11, 13, 15. What's the probability that it's a divisible by 5? So that's 5, 10, and 15. So those are 3 out of 15. There's something wrong here. Hold on. The probability of odd. What's the probability? 1 to 50. I'm selecting that has an odd number and is divisible. Okay. So those are not two independent events. I'm sorry, I was quickly. Okay. So let's just do quickly. I'm sorry, I was just like quickly on the wrong track. So what's the probability? We have 15 balls. And basically we want to know the intersection of the 15 balls. We didn't assume independent events. So we are interested in so those are the odd ones. Odd, and here we have divisible by 5. Okay, so we are interested in the probability of this and so the intersection. Okay, what are all the numbers? Okay, so we have 1, which is odd, but it's not a divisible by 5, so this goes here. Then we have 2, 3, 4, 5. So 5 is a divisible by then we have 3 is also odd. Then 5 we have, then we have 6, 7. 7 is odd, and 8, 9, 10 is divisible here. Then 11 is odd. Then we have 12, 13, 13 is odd. Then we have 14 and we have 15. 15 is a divisible. So it's 2 over 15. So we are interested in this intersection here. Odd, and so 2 out of the 15 events are divisible by 5 and odd, so the 5 and the 15. Okay, first I thought about independent events. Okay, a spinner has regions number 1 through 18. What's the probability that the spinner will stop on an even number or a multiple of 3? Actually, before I do that, the other numbers here, well, they are just out there. They're like 2. You know, here we have the 2, the 4, the 6. I just forgot to mention that. And the 8, and the 12, and the 14. But the entire set is still 15. Okay, so now a spinner has regions number 1 through 18. What's the probability that the spinner will stop at an even number or a multiple of 13? Okay, so now we do the same problem. So we have a total of 18 fields. Okay, what's the probability will stop on an even number or a multiple of 3? Okay, so that's probability even or a multiple of 3, M3. Okay, so that's again mutually non-exclusive events, or not mutually exclusive. So that's the probability of even minus the probability of a multiple of 3 minus a plus minus the probability of even and a multiple of 3. Probability that it's even is 2, 4, 6, 8, 10, 12, 14, 16, 18. So 2, 4, 6, 8, 10, 12, 14, 16, 18. So that's 8. Over 18. Divisible of 3, so 6, 9, 12, 15, 18. 3, 6, 9, 12, 15, 6. Well, it's obviously a 9 here. Minus the probability even and a multiple of 3. Okay, so that is a 6. Then the 12 and the 18. So that's 3 over 18. So 9, 15 minus 3, so 12 over 18. 12 over 18, or we divide by 6, 2 over 3. There are 2 bowls of balls. Bowl A has the balls numbered 1 through 7, and bowl B has balls numbered 1 through 4. What's the probability of drawing a 7 from bowl A and a 4 from bowl B? Okay, this is now independent events. So that's the probability of A times the probability of B, and event A is 1 over 7 times 1 over 4, so 1 over 28. Which of the following is concerned with a permutation? Selecting 3 students to attend a conference. No, the order doesn't matter. Selecting a lead and an understudy for a school play. Yeah, there is a lead and an understudy, so the order is there. Selecting 5 fruits for a fruit salad. No, the order doesn't matter. Selecting 5 different colored pencils for a pencil case. No, the only permutation is the lead and understudy. Which of the following is concerned with a combination? Trying to solve the secret code of an ATM card? No, that's a permutation, the order matters. Selecting a chief, assistant chief, and a chief assistant to the assistant chief? No, the order matters too. Cracking someone's computer password? No, that's a combination. So, a permutation too. So the only combination is the flower bouquet. Okay, evaluate choose 4 from 2 permutations. So let's write that down. So from 4 choose 2, but permutations. Again, for permutations, the formula was from n choose r, and that's n factorial over n minus r factorial. Okay, so now if we want to evaluate it by hand, and we will do it in Excel in a second too, so that would be equal to 4 times 3 times 2 times 1 over n minus r 2 times 1. Okay, so times, now the second one is 5 factorial. So 5 times 4 times 3 times 2 times 1 over 2 factorial, 5 minus 3, 2 times 1. Okay, so now this cancels out, and now we get 12 times 20, and that is 720. Sorry, it's not 5 times, it's 60, sorry, 12 times 60. Okay, and that's 720. Okay, so 27, so now we evaluate combinations. Again, the formula for combinations is n, choose 2, and now we have, in general terms, with r. Okay, so this would be n factorial over r factorial, that's a difference to the permutation, times n minus r factorial. Okay, so let's evaluate it. This is 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1 times 5 factorial, 5 times 4 times 3 times 2 times 1 over 3 factorial, 3 times 2 times 1 times 5 minus 3, 2 factorial, 2 times 1. Okay, so now this cancels with this, and then we have 12 over 2, which is 6. The second term, 3 times 1, so we have 20 over 2, so that's 10. So the answer is 60. But of course, we will do that in Excel. So in an Excel, we can also calculate and multiply. So for example, we can say, okay, so the first one was permutation. We can say permut 4, 2, so from 4 choose 2 times permut from 5 choose 3, and that's the 720. And we can do the same for combinations. Combine from 4 choose 2 times combine from 5 choose 3, and that's the 60. Okay, for any subset from a set of 2 or more elements, there are always more combinations than permutations, more permutations than combinations, and of course, there are always more permutations because the order matters. Okay, so 29. A teacher is making a multiple choice quiz. She wants to give each student the same questions, but have each student questions appear in a different order. So those are permutations. If there are 30 students in the class, what is the least number of questions the quiz must contain? Okay, so let's take a look at this problem and let's ask ourselves first, is this concerned with permutations or combinations? No, because the order matters. Because if it were combinations, so she wants to give each student the same questions. Okay, but have each student questions appear in a different order. So that's clearly concerned with the permutation. Okay, so we have to deal with a permutation. And if everyone has, so we need to have 30 different permutations. So we have 30 students, or not 30 students, we have n questions and we choose R, right? But R is actually equal to n because everyone gets the same exam. So the question is, how many questions do we have? But we want to give each student the same exam. So n is the same as R. R equals n. So that's here a little bit the trick. So that means we need to solve n factorial over, and then we have n minus r factorial, but that is 0 factorial, and that's important. 0 factorial is 1. So our problem becomes what n factorial is greater than or equal to 30. Okay, so now we can start reversely. 1 times 2 is 2, times 3 is 6, times 4 is 24, times 5, 1, 2, 6, 24 is 120. Okay, so the first number greater than 30 is when n is 5. So the answer is 5. Okay, which of the following is not equivalent to the following combinations from 6 choose 5? Okay, so let's first write this one here. So from 6 choose 5, that would be equal to 6 times 5 times 4 times 3 times 2 times 1 over, so r factorial, so 5 times 4 times 3 times 2 times 1 times n minus r times 1. So now this cancels out and this answer has to be 6. Okay, what about this one here? So what is from 6 choose 1? Well, that's 6, 2. How many ways are there to choose 1 from 6? But formally it would be 6 times 4. 6 times 5 times 4 times 3 times 2 times 1. And now 1 factorial. And now 6 minus r, so that's 5 times 4 times 3 times 2 times 1. So that's also 6. And here we have 6p5, okay, so permutations over, oh my goodness, okay, so of course we could use Excel too, but so far we have always gotten 6, and here we already have a 5, so it's probably D, but let's just double check that when we use permutations and we choose from 6, 5, what we get. So this is 6p, let's see if this is also 6. 6 times 5 times 4 times 3 times 2 times 1, okay, over 6 minus 1, so that's 5 factorial, n minus r, that's 6 minus 5, so that's 1 factorial, so there's only a 1, but we still divide by 5 factorials of 5 times 4 times 3 times 2 times 1. So again, we get indeed 6. Okay, so the correct answer is D, because the answer should be 6. So let me quickly do that in Excel too. So let's do that in Excel. Okay, let's start with A. The good thing is we can also use the term factorial, fact. Okay, 6. And now divided by 5 factorial, 5, and factorial 1, so we can divide again, factorial 6 minus 5, or you can also do it like this, 6 minus 5. So that's 6, so now let's do B. That would be combine. Okay, from 6, choose 1, 6. Now the next one is permute. From 6, choose 5, divided by factorial 5, it's 6. Okay, so Excel is really very useful for such things. Okay, so here's another problem. A coach must choose 5 starters from a team of 12 players. How many different ways can the coach choose the starters? Okay, so it seems that there is really no particular order in that. So the correct answer is that we have to choose from 12, combinations of 5. So that is 12, C5, so that is correct. Okay, so we can actually already calculate this. And so now we know that the correct answer has to be equals combine from 12, choose 5. Okay, the correct answer is 792. Okay, so it's definitely not D. But let's see what we get for answer B. So that is equal to permute from 12. From 12, how many ordered ways are there? 5. Divided by factorial of 5. Well, that's also 792, and we know that this is the correct answer. So that means we can so both A and B are correct, because it must be 792. Okay, so the local family restaurant has a daily breakfast special in which the customer may choose one item from each of the following group. Okay, so how many different breakfast specials are possible? Okay, so let me do that in Excel. Well, let's first do it. Okay, so we can choose basically from 3 breakfast sandwiches, we can choose 1. So that would be 3, from 3 choose 1. Then from the sides, we can choose from 4, 1. So technically this would be choose from 4, 1. And then we have choosers 1, 2, 3, 4, 5. And then we can also choose 1. So times from 5, choose 1. Well, because the formula is for combinations NCR equals n factorial over r factorial times n minus r factorial. Well, this just becomes 3, because if it's 1 to choose from, the only thing that's left is the n. So 3 times 4 times 5, and that is 60. Okay, so the question is 5 factorial over 3 factorial also 60? So we have 5 times 4 times 3 times 2 times 1, 5 factorial over 3 times 2 times 1. So now this would be only 20, so the correct answer is only A, 60. Okay, so I think those are the last 2 questions. A soccer team consists of 11 players. 1 goalkeeper, 4 defenders, 4 midfielders, and 7 midfielders and 4 strikers. Okay, so we have to have 1 goalie. We need to have 4 defenders, and we have 4 midfielders on the field, and we have 2 strikers. Okay, so 1, 5, 9, so those are the 11 players. But we can choose, we have 20 players in the team, so we can choose from 3 goalies. And we can choose from 6 defenders. And we have 7 midfielders and 4 strikers. Okay, so now we have to choose from them. So let's do that again in Excel. So the way to do it in Excel is to say, well, we have choose from 3 goalies 1. But now we also need to choose the defense, the midfield, and the strikers. So this is basically the multiplication rule, because this and that, so goalie and defense and midfield and offense, so times combine. Okay, we have 6 defenders, we have to choose 4, and combine, we have 7 midfielders, and we have to choose 4, and we have 4 strikers and choose from them 2. Okay, so that should be the answer, and it's 9,450. So that's the answer. Okay, so this should be the last question. So serial numbers for a product are to be made using 3 letters. using any of the 26 letters of the alphabet followed by 2 single-digit numbers. For example, JGR29 is one such serial number. How many serial numbers are possible if neither letters nor numbers can be repeated? Okay, so clear example of permutation. So the first 3 letters is, so we choose from 26 how many permutations are possible of size 3, n times the serial number. So we have to choose 2 numbers from 10, so 0 all the way up to 9. So from 10, choose 2. Okay. So let's do that in Excel quickly. Okay, so we can say equals permut (26), choose 3 times the numbers of 2, permut from 10, choose 2, and then we get 141 million okay, 1,400,000 okay, so that's C. Okay, so, and of course, what would be the answer if, let's say, if the numbers could be repeated? So then we would have actually 26 raised to the 3 times 10 raised to the 2. So that would be the answer if we, so then we would say this would be equals to 26 raised to the 3 times 10 raised to the 2, or 100. And you see, then we would have like some 300,000 options more. So what is that? 757 600. Okay, but anyhow, that was not a question. So yeah. So that was just a review again of some of those multiplication rules. So it has been a long problem set, but I hope that things become slowly but surely like second nature. So just let's stop here, and then we still do another problem set related to decision analysis.